I want to hear about. Obviously, you haven't solved this yet, but like sort of the plan of attack, because sort of what it
Hmm.
sounds like is like, okay, you say for n equals 5, here's what it would be. For n equals 6, here's what it would be. And you sort of, my guess is you'd sort of try to find some sort of pattern and then generalize. So is it
Yeah.
sort of like a do it, see what that gets you, do it, see what that gets you, and then you're trying to figure out the pattern? Or is there like a better, more analytical way to approach it?
So I think that like strategies like that are definitely still something that I'm learning because this is my first like real research experience. But um thinking about basically right now it's like okay, I'm considering the relationship between these sets of parentheses and these triangulations towards the end of trying to answer a question about chords. So the process has been like, okay, well now I understand they both are connected by these things called Catalan numbers. And so I did a lot of work on like, so what are these numbers? What is the recursive relationship between them? There's something called a generating function, which helps you solve that recurrence and create a general formula, um, which I looked at briefly and will probably return to. And then I started moving into like, okay, so I'm trying to figure out basically things related to Catalan numbers and something like triangulations and something like parenthesis strings. Like there are different interpretations of the same set of objects, but you could do different math on them. So like a triangulation is like geometric and you can do geometric things with it. But a string of parentheses, that's algebra. Like that's
Right.
associativity.
Okay.
So it's like, can you answer the question in a different way using a different field? And like one of those ways might be a little bit easier or a little bit more straightforward. Or like maybe I have like a personal like set of knowledge that's like more related to algebra than something like geometry. So like making those translations is why that's why like I'm doing that. But so then I was like, okay, I'm trying to answer questions about like which of these triangulations share a chord. Let me figure out like how I can tell if like a particular string of parentheses that corresponds to one and only one triangulation. If like you give me two of them and I don't have their triangulations, how could I tell from just the parenthesis strings whether or not they share a chord? And there's like I like kind of developed a
Hmm.
method to do that, which is try like translating the parentheses into a degree sequence of vertices. And then there are certain properties of that degree sequence which can tell you whether or not it will, when you draw that picture, that you will have one of those chords in common. Um,
And so is a big part of this process learning about all the other research that's happened on the subject. Like I'd imagine that's really helpful.
Definitely, yeah, it is super helpful. And it's kind of a double-edged sword because so for instance, like one of the things that I kind of came across when I was like looking at basically I had like the set of 14 for a hexagon, 14 triangulations, and I was like, okay, I'm gonna draw a graph where all of the vertices are the different like they represent different triangulations, and I'll draw an edge between two vertices if they share all but one edge. So if they're similar in every way except for one chord. And what that generates when you look at it in an n plus two dimensional space is something called an associahedron, which I had no idea was a thing. And it's like this really cool like polyhedron three-dimensional object, three dimension only specifically in that case. But like that and then I was like, okay, I've made this picture and I was like, whoa, this like it's basically it's a shape that has three square faces and six pentagonal faces, and it's made by like every edge that connects a vertex and that picture means that you've performed one application of the associativity rule on your string of parentheses to get between the edges. And then I was like looking it up and like it's called that because some guy already did all the research about that and like has learned about that particular structure of polyhedron and like has published things about it. And so it's like it's both like that's a good sign. It's like, okay, I'm moving in the right direction. Like somebody else found this interesting and I should probably read about that if I want to go down that path. But also then it's like, okay, like someone already did the work here. Like I don't need to
What's the
do it on my
point?
own
Yeah.
again. Yeah.
Oh, was this the stuff you were talking to me like yesterday about?
Was I?
We were talking to the car or something, and you were like, "Yeah, I found out this thing," and then I Googled it, and someone had already like researched it. So I'm like, "What's the point of me researching this if someone's already done it?"
No, yeah, pretty much. It's like because there are so many of these different Catalan objects, there's so many rabbit holes to go down. Like,
Hmm.
and this is true for a lot of math research, but like particularly with this problem, there's just like so many different directions that you could theoretically go down. And it's like, okay, I stumbled upon something that was really cool, but it's like already been like that path already had someone already went down that way. So
Right.
like I could go and
Okay.
research it if I was like personally curious about it, and maybe it will help in trying to answer like my own question. But doing more work on like the geometry of that polyhedron, not really worth my time. Somebody else already did it.
But it's pretty cool. So what you're doing specifically, no one else has come up with a solution for. Is
Not
that
this question, correct? Yeah.
it's pretty
Which
cool.
is
Listeners,
it's
feel
pretty
free to
cool.
give it a shot.
Which means
Yeah.
maybe I will not find an answer. Is the other
Uh,
the other thing?
Maybe you will. Maybe you will.
Who's
I'm
to say?
Be
I'm
pretty cool.
curious, like,
Yeah.
because like, okay, my first thought of like how you would solve this, if like you presented this problem to me, I would figure out a way to like make a computer program that could simulate this, or could sort of like take some n-gon and like
Yeah.
try to figure out the different connections and how many triangulations, and like do that, and then I would like have it run for 1,000, and like, so okay, I'm gonna say it first, and then I think there might be a reason why this isn't a thing, but maybe you try with like 1,000 n-gons, and then you can sort of like graph the data and see if there's some sort of like function or curve fit that could like describe the relationship between all these points. Have you thought about, is that just like way too computationally expensive, or like have you thought about that, or
So programming for this problem definitely would be useful. Um, I don't have a ton of experience in it, but I like know a little bit. But like generating, particularly when generating images of like all the different triangulations, when you get to like a really high number, and generating like something like these graphs that like revealed the associahedron, definitely would even like require the use of a program to generate that for higher Catalan numbers.
right?
However, the explanation of why is not going to be able to, you can't like, your program will not be able to tell you that. Like, why, like,
It'll just spit out the answer. It won't be
it'll give
like
you
this is
data.
Well, right, and then I feel like the next step would be then, mm,
well, the
yeah,
research he's doing is all about figuring out what the association is so
right,
that
right,
he
right,
can program
right,
it and be like, "Oh, I want a 32 sided like triangulation. What is the da 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 da?" So
Yeah.
I don't remember all the terms that you used, so I filled in does.
That could be, I guess, the end result.
Yeah.
Do you know
Is that
any
you?
Well, it
Python or
sounds
any programming that could help with this? Like, I
Yeah,
imagine it could be
yeah.
really useful.
I do. I know Python, and I can program a little bit in C, and that there's also definitely like particular like math software that is better for
Hmm.
generating these images or generating this data, but I don't have
Makes
that
sense.
like particular skill set.
mhm.
So I'm working the old-fashioned way, I guess you could say.
Yeah. Well, it sounds like you're doing a lot of frankly groundbreaking work.
Ah,
Trying
sure.
to
Let's
answer
call it
trying
that.
trying to answer a question that no one before has answered.
Yeah.
We're right at the end of our time. I would like to formally thank you for coming on the podcast and
Thank
Yeah,
sharing
you
your
this
guys.
is great.
insights into
Thanks
the
Thank you.
world of
for
math.
We
There's a
definitely
lot
like,
more in math than I expected.
I think the three of us combined still don't understand it half as well as you do, but like,
Oh,
no,
absolutely.
but it's very cool to hear
We need to do
about.
some research.
Yeah,
Yeah.
and then
Yeah,
we'll do research. We'll find out it's already been solved, and we won't tell you
yeah,
because
no,
you
when
just
we
feel
have my
bad.
research experience. No, I appreciate
Yeah.
you. It's definitely difficult to try to explain. So I know it's a little bit dense, but I appreciate the y'all letting me try
Yeah.
to unpack it a little bit with y'all.
Maybe next time bring a
Of course.
whiteboard.
Yeah, that could be
Next time
helpful.
Yeah, we'll hold that.
no, next time he'll give us a solution.